on the recorder just to make sure we're recording. And we seem to have most of the diehards with us. And I am now recording, Kay. Thank you very much. Association, Computer Professionals Association. I always get corrected. Everything I say gets corrected. Right, where was I? Oh, yes. We had just finished a very long and detailed view of all about how you modernize your database. And in the break, I'm sure you've all rushed off and you've started enthusiastically and are probably virtually finished by now. So we can move on to the next part of the modernization process, which is now talking about modernizing the RPG code itself. To take advantage of the modernized database, we want to now modernize the RPG code. So let us look at that as the new starting point for the conversations that are going forward. RPG4. And I'm going to say this again, there is no such thing as RPG ILE or ILE RPG. What you're seeing in front of you there is in fact the correct title. It is RPG4 for the integrated language environment, i.e. the language we use is RPG4. It comes in 3 flavors. It comes as RPG4 fixed form, which you can write. It comes as partially free, which means we used to call them calculation specifications, but we can't call them calc specs anymore because they don't have a C in them. Those are free. The data definitions are not free. And then you get in the later versions a completely free form in which you can write both the data description and data definitions and calculations in a completely free form mode. I must stress and I must beg you, when you change over and start moving to the free form, please don't believe that that is a license to make a mess. It's vitally important I loved RPG. I loved it more than anything because it was so well organized and you had to put things in certain places and it was nicely arranged and easy to read and you knew what everything was and where. Please don't see the freeform versions as a license to make a mess. In fact, when we move in and I start talking more and more about the different types of programming and all the modularization and fragmentation that we do to modernize our code and make it more dynamic, it's vitally important that you have some sort of consistent view of the code. And I know big shops, lots of people have a huge problem in this respect because everybody wants to code the way they feel comfortable with coding. And that means, once again, we get into this area that I call pigeonholing, where this person wrote that piece of code, nobody else can read it. And so always they have to fix that code or enhance that code or modify that code. So if they're all sick or are unavailable, we've got a major problem in our organization. And step 1 in modernizing RPG code, above and beyond everything else, is to determine, establish, and insist on a set of standards for the style that you're going to write your RPG freeform in. Unfortunately, I wish they'd left it as fixed form, because then you couldn't argue. You had to do it that way, otherwise it wouldn't compile. But obviously, we don't have that, so please understand that freeform doesn't mean go bananas. It means you can arrange it, but you need to arrange it so that all your code across your entire enterprise will eventually become consistent. You're not going to do it in 5 minutes. it really is going to take a while, and you are going to have, I know, I've been there. I had a war with 8 programmers. I visited an organization which had programmers as far as the eye could see a couple of weeks ago. They got more than 8. They're going to have a bigger problem. But you need to consider this as public enemy number 1. Random structures of RPG code with no consistency in them at all is going to create problems. I can't emphasize that enough. So, we have RPG4, either fixed, partially free, or completely free form, which has been optimized to operate in the integrated language environment of the IBM I. So that is what we're dealing with. We're dealing with RPG4 in the integrated language environment. Let's have a look. There are really only 3, the ILE components are modules, procedures, and functions. These are the things that make up RPG4 for ILE. And it's a lot simpler than a lot of people think. A module can contain 0 or too many procedures and or functions. And then those modules are then dealt with in different ways to give you different results. This is the key to ILE, or one of the components, or one of the methods around ILE, is you build code modules which you can then manipulate to give you results. Let me just once and for all identify the difference between procedures and functions. And I'm not going to talk about it again because it just gets tedious. They are identically the same thing. The procedures can optionally receive parameters and return parameters. A function is slightly different. It can receive and return parameters in exactly the same way as procedures do. But a function can also return a result, which can be used as part of an expression. And that's the big difference between procedures and functions. So when I refer from now on to a procedure, it can be heard, seen, and understood interchangeably as procedures and functions. I'm not going to say procedure stroke function all the time. I might just chuck it in every now and so often so that people don't forget what I've just said. But really, the ILE components are modules that contain procedures and functions. That's it. And depending on what you do with those modules, you can generate different types of things. So the situation here is we write source code, and we then compile it in one way or another. And these are 1, 2, 3, 4 compilers that are available as ILE compilers. These are the 4 compilers that allow you to build executable programs or callable service program procedures, etc., etc. And let's just quickly look at them. I'll come back to them again because we are going in we're going to do a bit of a deeper dive into this whole process. But create RPG module. That is a compiler that creates an object type called star module, and it is a compiled module, non-executable. Create program is a compiler that binds modules together to create a program executable, i.e. a program that you can call. based on a program call. Create bound RPG program. Create B&D RPG also does exactly the same thing as create program. It creates a program executable by binding one or more modules together. We usually use this and apply it only to a single module, which we then say is an ILE program. Not strictly true. Yes, you have used an ILE compiler to convert a module to a program, but it's a single module. The create bound RPG can bind numerous modules together to create a single program. And then the last one is the create service program. A service program, star SRVPGM, is not executable, but the procedures within it, i.e. the procedures that are within the modules that have been bound together to create a service program, the procedures can be individually callable. So a service program is actually a library of callable procedures. And those are the 4 compilers that are used within the ILE environment. Okay. I don't suppose there are any questions at this stage, but I've got my little question mark popping up to see if there are any. I'm sorry if I burst your bubble about RPG ILE, but we have to be exactly and precise in terms of terminology. Otherwise, we tend to lose it. Okay. Moving on. The integrated language environment is an environment in which it's actually exactly what it says. It's an environment where different languages can communicate and pass control backwards and forwards to each other. So I'm only focusing during this exercise on the RPG4 portion of the integrated language environment. But the other languages, CLLE is CL for the integrated language environment, and that is an ILE language. There's C, there's COBOL, there's a whole lot of languages which subscribe to the parameters and the benefits of the integrated language environment. So, what is the integrated language environment? And I think the most important thing to understand is that the integrated language environment is a series of boxes. Now I'm looking, I think I've got my slides in the wrong order, so just excuse me for 1 second. I just want to look at something. No, maybe not. Maybe we can go this route. The integrated language environment mainly consists of activation groups. An activation group is a box that contains certain resources, and you can have boxes within boxes. And the integrated language environment operates within these activation groups. So let's just go down and have a look at some terminology. What are they? An activation group is a frame that encompasses a particular set of programs that are being executed and manages the resources and the commit cycles around that particular set of or around that particular box. I am actually going to switch the slides. I added some slides in here, but I need to change them. So I'm going to move down. Right, the types. There are 3 different types of activation group. We'll discuss those in detail. And the why is, why do we have activation groups? Well, the activation groups enable ILE. Without without an activation group, you can't use ILE, Integrated Language Environment, because the activation group is ILE. So let's just have a look at, I'm going to see if I can find the slide I want to look for. Is it this one? Yes, it's this one. Sorry, I'm going to be hopping around a bit. I'll adjust this later, but I'm not going to do it now. When you start a job on the IBM I, and you will see it every time you look at your call stack, and I'm going to pull that in here. I'm going to pull a little green screen in here, and I'm going to do a shift escape and a 3, and then I'm going to call up the call stack. And at the top of every call stack that you can see, unless you have been fiddling with the basic configuration of the machine, you will find a program called QCMD. Q command. That is the command processor for the operating system, and that is at the beginning of every single call stack. It is the first program that is called and initialized when a job starts on the system. And Q command is the program that initializes the first and the default activation group. So a job exists inside a default activation group. And this is what makes the IBM I so resilient to all sorts of things, because there's there's a fence around this job. The fence is in fact the boundaries of the activation group, and you can't get out of that activation group and go and corrupt somebody else's job. You have to remain and process within the activation group. If you go out of the activation group, you're going to get errors. So we have a default activation group. That is a situation that exists when you log on. You log on, you create a job, and you create a default activation group, and Q command gets initialized. Now, you can only terminate this particular activation group by ending the job. So you start the job, you get your default activation group, and you terminate the job to close down the default activation group. The default activation group, or DAG as people like to call it, it's a little bit acronymish, is where all your OPM program objects run, as well as all the operating system functions. The entire operating system operates in the DAG, default activation group. And your OPM programs, which are those that occurred before, I'm not sure, I don't know whether it was RPG 3 or RPG 2. They all run in the default activation group. In fact, they are non-ILE type programs, and therefore they run in the default activation group and are not able to run in any other activation group. Right. Now, in addition, and this is the interesting part, and this is to some degree what confuses people about ILE and activation groups. In addition, there's limited function RPG4 programs can run in the default activation group. Limited function is defined as programs that don't contain any procedures, don't call any procedures, and use no contemporary built-in functions, as well as any features that require procedures not supported by the default activation group. Some operating system procedures are supported by the default activation group. So you can write programs, and you can compile them using the create bound RPG. And they will run, but they're not ILE programs. You can't use procedures. You can't create procedures. You can't call procedures. You can't use some of these fancy new built-in functions. So you might think that your program is an ILE program when in fact it isn't. All right. So your default activation group, coming back to here, you can see Q command, and then you always get right down to the bottom. And of course, the last entry in the call stack is the current program that is active. I don't have anything switched on here, so my call stack is quite short. And if I display the activation group using F11, you will see that all of this is running in a default activation group. The control boundary is at Q command level. The control boundary has special significance, and we'll talk about that later. And all these others are running in a default activation group, which has an activation group number of 1. All right. So let us have a look at, I'm going to go backwards, back to where I was, because I want now to talk about that. That is what is an activation group. The default activation group is used for operating system and OPM model programs. Let's have a look at some of the terminology that is around the whole ILE environment, because it's important to understand what it is that these things mean, because they actually, the power in ILE is far beyond what? Sorry, just hang on a sec, people. Right, sorry about that. Had a little interruption. My grandchildren have come for a visit. Programs and service programs are the two main structures within the ILE environment. Those are made up of modules, code modules, which can take two different forms. And this is what one needs to understand. Because if you're going to write and put together efficient, agile business logic, you need to understand how the programs can be constructed. So modules contain procedures, sub-procedures here, which are what used to be subroutines. And one of the first things one can look at when you're beginning to migrate into an ILE environment is to change your subroutines into procedures. It's easy to do, and it does tend to move you along the path without creating too much of a high risk. Sub-procedures and sub-functions are those procedures that are used only within one particular module, whereas procedures and functions are usually exported and are used by more than one module. So this is a terminology differentiation. When I talk about a procedure, it could be a sub-procedure, but it could also be a procedure inside a service program. There are two types of modules that you can create. There's a thing called a cycle main procedure module. And this one is the good old faithful module that we used to write that contains the entire RPG program cycle. I'm sure you all know the RPG program cycle, are very familiar with it, and actually wish you could use it again. The other type of module is what they call a linear main procedure module, in which no cycle is available, i.e., this is a method of dropping the RPG cycle code and creating yourself a linear main procedure module, i.e., you code from beginning to end. There's nothing implicit. There's no cycle. That's why it's called linear. Okay, so those are some of the terminologies in ILE-Speak. Let's see how they apply. The standard one that most of you are probably using at the moment, I would say. Cycle main procedure module. This is the normal one. Even if we are not aware that we're using the main line, the cycle, the RPG cycle, it is still there. And this is typically the type of program that people are using, even if you're using procedures. Here. You're probably still using a cycle main procedure module. Let's have a look. The module contains a cycle main procedure and 0 or more sub-procedures, i.e., there's a module. And the cycle main procedure is that part of the code that you write before the first procedure. So this part of the code, the C-specs that you write here, sorry, my drawing of lines has not improved one little bit in the last couple of weeks. That section that is coded before the first procedure is coded, or sub-procedure is coded, that is what we would consider to be the cycle main procedure. It has a name, it is the name of the program, and it is callable. So that, and of course the global definitions are part of the module, and these file specifications are part of the module. And by default, a cycle main procedure module constructed in this way has a program entry point, which is by default the first calculation specification. That is defined as the program entry point. The cycle main procedure includes the logic for the full RPG cycle. At the moment, approximately 25,000 lines of code, I'm led to believe. I have not verified that. So if any one of you has great enthusiasm and wants to go digging in the papers, you can verify it for me if you like. But it is a significant amount of code. It's a significant amount of logic, which the majority of programs written today use very little of. And I'm fairly certain that even in your applications, your current heritage or legacy systems going back 20 years, I'm pretty certain one of the first things anybody ever did was to get rid of the RPG cycle. And so I'm not sure that it is used, and yet we include that code in all our programs. A cycle main procedure can be called through a bound call or through a program call, i.e., and this is actually quite important, that, sorry, what did happen there? The program entry point of a cycle main procedure is in fact the procedure name. If you look at your call stack, when you go, let me just find a, here's one. I'm just looking for a call stack entry that I can show you that, yeah, here we are. Here's one. If you look here at this particular program here, that program in that library, this, by the way, is the AO Foundation main menu. You can see it's indicated as a PEP. It's got a program entry point. So this is a program entry point, and yet immediately following it is a procedure of the same name. So when you do a create bound RPG, you are creating the module or the procedure. This main line is a procedure which has the same name as the program. You can see it again here. AOFG is a PEP, and AOFG is a procedure immediately following it. So the main line, the cycle main line, is callable through either a bound call as a procedure or as a program call as a program. So you can call it one of two ways. And the bound call is always more efficient than the program call, because that call is set up at compile time, not at execution time. So that's the cycle main procedure module. Obviously, you can have multiple procedures. They can be sub-procedures, but here I'm going to throw in a warning. It is possible, and nothing will stop you, defining a sub-procedure inside a cycle main procedure as an exportable procedure, which of course then becomes callable directly from another program. And here's the warning. If a module contains both a cycle main procedure and exported sub-procedures, take great care to ensure that the RPG cycle in the cycle main procedure does not adversely affect the global data, files, and data areas that the sub-procedures are using. Because remember that if you call a sub-procedure which is being exported, it's dependent on the global data files and data areas in that module. And you've got to be aware that when files are opened and closed implicitly, when data areas are locked and unlocked implicitly, and when global data is initialized and reinitialized. So what is being said here is that if you choose to mash RPG4 and ILE and try and mix and match your programs and your service programs into single objects, be it on your own head, you better be absolutely 100% certain that you understand the RPG cycle in absolute detail if you ever export a procedure from a cycle main procedure module, because it will bite you somewhere. Now, I know that people like doing this because it seems to be a shortcut, or it might be. It would be better if you wanted to do that. It would be much better to take that service procedure, that procedure, out of that program altogether, or out of that module altogether. place it in a service program, and call it from there whenever you need to use it. My advice is never export procedures from a cycle main module. Okay. At this point, are there any questions about cycle main modules, procedure modules? Of course, the rules are the same. You can still send me emails with questions, so please make notes if you have them. You can send me questions by email and we can answer them at a later stage, but if you have something. Okay. Linear main procedure module. It's a module. It has or can have file specifications. It can have global data definitions or not, as the case may be, doesn't really matter. But they are all defined at the top of the module before the first procedure definition. The balance of the module is made up of procedures. These procedures can carry file specs, local data definitions, and procedure code, or not. And there can be one or many procedures into this module. However, what makes this a linear main procedure module is this keyword that has to be used during compile. During compile, or on an H-spec is where I usually put it because it then doesn't get forgotten. You name the procedure that's going to be considered as the main entry point, i.e. the program entry point. It does not have to be the first procedure. Doesn't. It can be this procedure here. The name of that procedure can be put there, and that will make that procedure the linear main procedure entry point, i.e. that is the entry point that is used when this module is called. Remember again what I said earlier. This module could also be a program. Depends on how it's compiled. We'll look at the compilers again later. The module contains a linear main procedure and 0 or more ordinary sub-procedures, i.e. it's got to have a minimum of one procedure, otherwise it has no program entry point. Now notice I'm talking about modules all the time here. I'm not talking about programs. We're not even thinking in programs, because with ILE, you begin to think in code modules. And then you bind and build the code modules together to suit what you want to do. So it's modules we are thinking about. The linear main procedure is identified by the main keyword on the control spec. You have to have the main keyword on the control spec to indicate where the program entry point actually is, i.e. it's the first procedure that gets called when this linear main procedure is called. The main procedure itself is coded as you would code any normal sub-procedure, with procedure specifications and optionally parameters as well, if you want to pass parameters into that procedure. So it's coded as a sub-procedure. It can only be called through a program call. And this is important. It can't be called using a bound call. So if you try to call it, it'll fail, and you might not actually be able to find this for quite some time, because it doesn't come up in a nice, easy to understand manner. It just says a call failure. Other than the way it is called, the linear main procedure is considered to be a sub-procedure, i.e. it's coded the same, it's dealt with the same, it's a sub-procedure, and the module does not include the logic for the RPG cycle, i.e. in this particular form, the 25,000 odd lines of code are not part of the compiled module, which means that the modules are, to a certain degree, smaller, which means that when executing, they require less memory, less, etc., etc., etc. So there's some advantages to getting rid of that mainline procedure, apart from the fact that when the cycle main procedure is active, it executes a lot of statements that don't do anything, but it still has to go around the cycle. Believe it or not, you think the RPG is not going around the cycle, but it actually is. But it's executing components of that cycle that really are redundant, useless. So that is a linear main procedure module. Then we have the third type of module, which ILE lends itself to. And that is what we call the NOMAIN procedure module. The keyword at the top is NOMAIN. There it is there. The NOMAIN keyword on the control specification indicates that there is no main procedure in the module. The module contains only sub-procedures, and the module does not include the logic for the RPG cycle. So this is a procedure or sub-procedure only module. And remember, as I said earlier, that also implies sub-functions, because sub-procedures and sub-functions are intrinsically identical. It doesn't include RPG logic, and there is no program entry point through which you can call this module, bound or program call. There is no way of calling it. In a NOMAIN procedure module, only the individual procedures can be called. So the procedures here in a NOMAIN program are individually callable if you have allowed them to be. And that's the important thing. Some of these procedures in a NOMAIN module might only be there for the use of other procedures in the same module, in which case they're not callable. Now, this type of procedure forms the basis of service programs. The NOMAIN procedure module is the basis of all service programs. That's how we code our service programs, as procedures within NOMAIN modules. And we bind them all together to create a service program, and so on and so forth. I will go through the service program structure again. We did it once before, very fast, when we were looking at the I/O services. I will go through it again, unless you all write me a note saying, don't do that, we're quite happy, we understand absolutely, in which case I won't. Okay, so that's the NOMAIN. Let's have a look at some of the things. You've seen this before. I copied these slides down from up the top. Because now you've got modules. We've talked about the three types of modules. The first one on the left here is actually a module that is created immediately as a program using the create bound RPG. Now, the create bound RPG has to have a source, and I can also bind other modules into that program. So this program can bind its main line with, of course, a built-in PEP, because that is by default what happens, and you've got a cycle main here. It can even bind in a second module that is also a cycle main module. That's a big waste. But you might want to use the main line in here as well. And it can bind into a module that has only got procedures. And these two are created using the Create RPG mod and the Create RPG mod. So that can, using the Create Bound RPG compiler, that can take one or more modules and combine them all into a single executable program. Which, by the way, because it's a cycle mainline, can be called either from a direct program call or from a bound program call, a bound call. Here's another way of creating a program from modules. Here you have a module. It's a cycle main module. I can tell that because it's got a main line. It's got a PEP. So that's the program entry point, and it's got a second module. These two are created using Create RPG mod in both cases. And then these are bound or compiled into a program using the command create program. That takes one or more modules and it creates a program executable from the modules. In this particular case, you have a cycle main module with a program entry point, which means that any call made to this program is going to come in that point there. And that's the program entry point. These procedures are available from this module to be called. Even though they exist in a different module, they are callable. The global data definitions between these two modules are shareable because you can export the one to the other. So there's a common global data area there as well. So when you're putting together modules to make programs, you've got, the first thing you've got to understand is that actually there's a lot of commonality here. The global data definitions are common across the whole program, if you choose them to be so. They are common to all the procedures in a module, the global data definitions. Procedures can be called from one module to another and from the other module back to the first module if you want to. You can call across these things. This is what makes ILE what it is. The ability to break down your code into small, digestible, easy to write, easy to modify, easy to test components, little pieces, and then reconstruct them to produce a result that you need. Here's a program that's created. Now, I have spotted a mistake here, and I'm not sure. I wonder whether any of you can spot it. These are modules, 3 modules. Oh, no, there's no mistake. It's just that I haven't been very clear about this. Notice that there's no cycle main here at all. So you create these 3 modules by creating create module, and create module. And then you're going to now create a executable program by using the create program command. But here, you've got to now look carefully at what you're putting together. Because you need, each one of these modules needs a control keyword. One of the modules needs a main keyword, main procedure name, and the other two require a NOMAIN. i.e., when you're building this program, you have to decide which of the procedures is going to be your program entry point. Assuming that one, this module will be the one that has the main procedure keyword, control keyword on it, and these two will have no main. So you've got to look at these modules and decide what you're actually going to do with them and what you want to achieve with them, i.e. you're putting them together. Now, it means you can take lots of little pieces, put them, build them into modules, compile and test them and do that sort of thing, and then you can combine them into a program which is then callable. And you can make some enormous programs, very efficient, large programs, very functional programs, but building them up in small little pieces. And I use this example. You guys call them Legos. We call them Lego in this country. This is the classic example, or a good example, of the picture of what you're looking for here. You want to create components, whether they're single use or multiple use components doesn't really matter. What you need to do is you need to build components of code that are easy to write. First of all, easy to specify and define, easy to write, easy to test, easy to modify. And then you build them together into modules, and those modules you then construct into programs. So it's a Lego construct, Legos. There's only one thing that you've got to consider when you're doing this sort of thing, using modules and procedures to build programs. This procedure here, let's, for example, assume that this procedure here requires change. This procedure is part of this module. This module is bound using create program into a program. If I change this procedure, I have to recompile the program. If this procedure is called by another module in another program, or this entire module is used in the construction of another program, then a change here is going to require that all the users of that particular procedure stroke module are going to have to be recompiled and retested. And this is an area where one has to be very careful. Again, like a lot of these things, this whole idea of having little bits and pieces and you can just assemble it like a Lego building is very appealing. But if it's not carefully controlled and standardized, you can actually find yourself with a serious problem in terms of the ability to actually promote any change anywhere. And once that happens, you then start ending up duplicating procedures in order to avoid changing existing stuff. So in the majority of cases, procedures that and modules that have reusability or need to be agile would not be bound into a create program for execution. They would be bound into a service program, and then a single program would then call the procedures that were required. And by doing that with a service program, you only have one place where you need to modify and maintain and test the procedure, and all that change then propagates itself automatically through wherever it is required, if you follow certain basic rules that I laid out earlier, and which we will go through again. All right, so let's have a look. Now that we know that you can create programs in various different ways, the next big question is, how do I create and how do I use an activation group? Because I have to use an activation group if I want to use ILE in the true sense of the word. So I'm going to get this little green thing here. The thing that creates activation groups is a program. And so the decision about the activation group that you are going to create and the type of activation group that you are going to create is decided at the time you compile the program. The program, a program is the initiator of a new activation group. And it is at the point that you compile the program that you make the decision as to whether this program is going to be part of an existing activation group, or is it going to create a new activation group of its own. And I'll show you the command. We'll use the most familiar one for the moment. You'll notice that the default here for default activation group is yes. Even the create bound RPG compiler, which is the ILE compiler, has a default activation group of yes, i.e. you're compiling this program for the default activation group, which means you won't be able to use procedures from this program or built-in functions or any of that stuff. So the first thing you have to do is make sure that that is changed to no, because we do not want to create a program using the default activation group. Now, okay, I've done it again to me. They've put in a new value in the latest release of the software. Here is where you define the type and the name of the activation group that this program is either going to execute in or create. The storage model is a new one, and I'm going to press F1 like all good people. If the storage model is TerraSpace, the program will be activated into the QILETS activation group. Notice that is a default name, QILETS for TerraSpace. Otherwise, this program will be activated into the QILE activation group when it's called. So it depends on the storage model that you are using, and this basically gives it a default name, QILETS or QILE. Okay, I'm happy. It's not too much of a change. So we have a name. The default name is given by that parameter, or we can provide it with any name we choose. I.e., we can name our own activation group. Or we can use star new. Now, star new says I want the system to name my activation group. Now, what is the difference, you might ask, probably would, between me naming it and the system naming it? These are two types of activation groups, and they behave very differently. I'm going to go into that in detail right now. But star new means it's a system-created activation group, and if you give it a name, it is a named activation group. Star caller is what you would use if you wish this program to execute in the same activation group as the program that called it. i.e., I'm not going to create a new activation group. I want to execute in the caller's activation group. So there are three types of program compilation, which you may or may not have used in the past. One is a named activation group. Two is a system named or star new activation group. And the third is star caller, which retains this program in the caller's activation group. This is, you can specify the binding directory, which is where the compiler needs to go to resolve its external symbol tables, external symbols or internal import symbols. So you can give it a list of binding directories. And that is what you get. Now I'm going to go to the other one, CRT-PG, and these two compilers are essentially exactly the same, except this create program lists, gives you a program name, lists the modules that make up the program, and specifies which module is the program entry procedure module, and then it asks you for the activation group again. And once again, we have the three: named activation group, new, and caller. The entry module, let me see, is the program entry procedure module is examined. If the module attribute is, then activation group is QILE or QLETS is used. So basically, entry module, if it's RPG, C, COBOL, or CL, then it gets the same default name as the other one. Don't know why they haven't standardized on that parameter, but that is it. So here, using create program, you specify which activation group type you are using for this program. So both those commands, those compile commands, have exactly the same activation group parameter. Notice one thing, however. In this create program command, you don't have to specify use default activation group yes or no. If you use the create program command, it assumes that you are actually creating an ILE program, and therefore you are going to be working in an activation group other than the default activation group. Okay. Let's have a look what happens. We've seen this before because I hopped here, so I'm not going to waste my time on that. I'm going to get into the next fun thing. Right. Here is the beginning of the process. Q command starts a default activation group, and everything that runs in this job runs within this activation group. That's a default. You can't change it. You can't do anything with it. Let us assume we create a program called Program A, and we compile it using activation group star caller. I.e., when we compile it using star caller here. Now, using that parameter there will mean that it will run in the activation group of its caller, which, in this particular case, because it's the first call, it will then run in the default activation group. Which means that this cannot be an ILE program in the true sense of the word. And it and its resources are bounded by the default activation group. If that program calls another program, Program B, and that program was compiled using an activation group star new, what happens is that a new activation group is opened and initialized by the operating system before control is passed to that program. So that program is actually executing in a system-generated activation group. And therefore, of course, can be an ILE program, can do all the wonderful ILE things that ILEs can do. And what's more, its resources from this moment onwards through these other two programs, which may have been compiled using activation group star caller, which means they are operating within the same activation group. All the resources for this activation group are managed by the activation group. And one of the things I have noticed when converting to ILE, there's no more set on LR. There's no more close files. If you use your activation groups effectively, the resources are managed under the covers by the activation group managers themselves. Okay, so here we have a program which calls another program, which opens a file and backwards and forwards. And within this environment, all the resources, and by resources I'm talking about open files, I'm talking about commitment control, and everything else, display files, disk files, everything. All those resources that are required are within this activation group. When you exit, now I'm not sure what the slide is going to do. No, this is right. When I get here back to Program B and I return control to Program A, this is where the different types of activation group begin to kick in. When I pass control back from Program B to Program A, because the green activation group was a system-created activation group, it is automatically closed by the operating system. It is closed down. And all the resources that were part of that activation group are closed. All the files that were open are closed. All the uncommitted updates are committed. The commit cycles are updated. All the program resources are automatically shut down. Everything relating to that activation group is shut down as if it disappears from the scene and control gets passed back to Program A, and all the resources are recovered out of that program, out of this activation group here. So having an activation group that's controlling resources Means you don't have to worry about opening and closing files and tidying up after you, because the activation groups do that for you. They tidy up. If you use a system-generated activation group, it closes down and tidies up when you leave. Of course, if you call program B again, it has to reinitialize this entire activation group from scratch. And of course, that carries an overhead each time. So you don't necessarily want to do that. The other option that you have is you can call a program that is compiled with a named activation group. Now, you can give it any name you like. Doesn't matter. Usually, it would be a good idea to give it a name that has some meaning as to its function or its purpose. Now, with a named activation group, it behaves in a very different manner. Here, I can call programs or procedures. I can have other programs that are activation groups, and they've got resources and everything open. When I exit this activation group back from this program back to that program, this activation group, because it's a named activation group, remains open. Sorry for the wobbly lines, really, it's because I'm left-handed. Because it's a named activation group, it does not get shut down. And that is a very, very important consideration. All the files remain open. All the program caches are initialized. All the file pointers are still pointing at the last position they pointed at. All values, group variables, and everything that was opened, initialized, or utilized within that activation group remains open. Even though control is passed back to program A, everything in this named activation group, which is a commit cycle, by the way, even commitment control. The commitment control is not committed. Sorry, 1 second. The activation group remains open and active. If I then come back from program A, I'll find the error, and call back again into this program here, the activation group is not initialized because it is already initialized. That means files that were open are still open. Pointers that were pointed to are still pointed to. In fact, if you wanted to play a game and run a test on this, it's actually, I've done it, and it's actually a very fascinating test because it proves the point. You can go into a program like this one, and you can do a chain to a file for update. Do a chain for update. Then you go out again here to program A, call back again to this program, call down to this program, and do an update without a chain to that file, which might be this file. And it will update it, because the last record that was read is the record that's being updated. You can actually do that test, and it works. So it means you can go in and out of this activation group frequently, as often as you like, without having to reinitialize any resources whatsoever. Obviously, it's a good idea to understand it so you know where you are every time you go back in. But it's an extremely useful technique if you're processing files of different transaction types, for example. You can have an activation group for each type of transaction that you're processing, if it's justified and if they're using different files and different program sets, which generally is the case. You're processing different things. And so you can go in and out of these activation groups. And of course, if a certain particular transaction type doesn't exist, then you won't open an activation group for it, because you won't call the program that calls that activation group, so that those resources will never be opened if that transaction type doesn't exist. So you can build much more efficient programs, and yet the resources are managed globally in the activation group. Oops. Right. How do I get rid of a named activation group then? Because that's the next question that comes to mind. Well, there's two ways you can do it. If for some reason something goes wrong in this activation group and an escape message is returned, if an escape message is returned back this way, i.e. an error has occurred somewhere in this activation group and causes an escape message to be sent back to the caller, then the activation group is automatically recovered, closed. Automatic rollbacks occur because it's being exited via an escape message. Uncommitted updates are rolled back. Files are closed, programs are closed, and the activation group is actually reclaimed and closed down. The only other way of recovering or reclaiming an activation group is by using a command. RCLACTGRP, reclaim activation group, F4. Activation group, if it's a particular one, you can say a named group. And you want a normal close on it or an abnormal, typically it's a normal close, so you would hit that. And when you hit the enter key, obviously, it said I didn't find an activation group called named group, therefore I can't reclaim it. But if it found a named group called that, which was active, it would have reclaimed it and all its resources. But this command to reclaim an activation group cannot be issued from within the activation group that you are trying to reclaim. It would have to be issued from this program here in order to reclaim an activation group, a named activation group. So you have the two ways. The one way is where there's an error and the activation group will reclaim itself. And the second way is from outside the activation group, you can reclaim it. There is an option here to this in that you can use star ELIGIBLE, eligible. This one, be very careful. If you are working with activation groups for a particular purpose and a reason, be careful. Because eligible simply means all eligible activation groups within the job are deleted, i.e. any activation group that is currently not active will be reclaimed. And that may mean that something gets reclaimed that you don't want to be reclaimed. So be very careful about using eligible. Rather use the names to reclaim very specific activation groups. Okay. Of course, this reality that we see here would not necessarily ever be true, because this green activation group is new. Therefore, if I ever went back to A in order to call D, this green activation group would always reclaim itself. It would close down. So this is not strictly speaking a diagram of reality. But here I have another activation group inside. This one is a new activation group. I keep losing this little pointer. It's compiled as a new. So program D, that shouldn't be program D, that should be program E. That program was compiled with activation group new. So when it got called, and this is important, it could have been called from here, or from here, or even from here. It could have been called from anywhere. But every time it gets called, it opens a new activation group. It has its own set of resources. It has its own commit cycle. And every time it exits back to its caller, whoever that might be, it will reclaim all the resources in that activation group. Okay, so I'm sure that you're sitting there thinking to yourself, what does this really mean to me? How can I use it? At the very least, the first program that you call in any process, I always call the first program, this first program in a process, this one here, I call this a driver. It's a process driver. It is the first program you call, probably from a menu or from a CL statement inside of whatever it is. That's a process driver. And at the very least, you need to make that process driver actually create an activation group. And preferably, a named activation group. Remember that if it happens to be the first activation group that you created and the job ends, the activation group is going to be reclaimed anyway. So if it was called as a batch job and the batch job runs, it opens its own activation group, which means you have full access to all the ILE functions. It can then run entirely in the one activation group. When it ends, the job ends and the activation group gets reclaimed. And everything gets closed down accordingly. So it gets tidied up. But I want to pose something here, because activation groups can get quite hairy if you're not careful. And this is why it's a good idea to do, if you want to use activation groups, think about what you want them for and how you're going to construct them together. Because consider a situation where this program here calls that one there. Remember, this is a named activation group, this orange one. Therefore, it's a named activation group. Therefore, it would still be open if I had called program B, and then through there ended up calling this program here. This activation group would have been open. This one would have been opened new when I called program B, and this would have called a program that's already part of an existing activation group. Now, I put these things in in this type of presentation because I carry the bite marks of having things like this happen to me. And they're not all that easy to find unless you're comfortable with the concepts. What happens in this particular case is this program here is compiled with a star caller. Therefore, this program will actually be reinitialized as part of this activation group because it's required to execute in the activation group of its caller. So, in fact, you will have two instances of the same program, one in this activation group and one in the named activation group. Now, I'm sure you can see that that could, if it slipped past in the design of this whole thing, it could end up creating a few wobblies. So, I think the message that has to come from this is that using activation groups are necessary in order to get hold and to allow you full function ILE capability. But please don't rush into these things with unnecessary enthusiasm without being sure of what you want to do with an activation group. So start by just having a single named activation group as is provided by the defaults. And that's the important thing to understand. Defaults are pretty much designed to make life simple. So QILE is the default named activation group in most cases. So it's pretty much a good route to start following. That gives you access to the full ILE functionality. Once you begin to understand how that works, you can begin to start looking at the constructs of your application and beginning to, first of all, break everything down into modules and then beginning to look at processing different functionalities through different activation groups for different purposes. So there is a lot of power here. It improves performance tremendously. It eliminates the need to clean up. It reduces the number of open data paths. It allows you different commit cycles. And this is a very important aspect. You know, if you're working in a single activation group and you've made changes to 20 files, and you issue one commit statement, all 20 files are committed. Now, that may or may not be what you want. But if your transaction is built in pieces, and you want to be able to manage the commit cycles of that transaction separately, then you would use activation groups. Have two activation groups with two different commit cycles, so you could commit one without committing the other, and so on and so forth. So there's a lot of power and performance and tidiness and cleanliness in the use of these activation groups, and of course the full-blown function of ILE. But if you don't, if you get yourself tangled in a knot with these things, they can actually become laborious and sometimes downright dangerous. And then what typically happens, and this is always what frightens me, what typically happens is that people will say, I can't make it. To hell with it. And that, of course, is not what we want to do. We want to get away from monolithic monsters of programs. We want to increase our ability to be agile, to modify, to test, and that sort of thing. And using procedures and activation groups is the way to do it. But you've got to do it in a controlled manner and in a steady manner that makes sure you don't get into the problems that are going to cause you to abandon it. Now, large shops, this is difficult. It's a hell of an exercise, a learning curve. But it can be done again in small pieces. For example, you just have to identify a function driver and compile that with a default named activation group. The rest just falls into place. You don't have to change anything else. But what it does mean is that that function, driven by the program, is now running in a genuine ILE activation group. Then you can start taking all the subroutines out of it and replacing them with procedures, looking for the common code and shifting those into service programs. So your first step in the whole process can be just as simple as compiling your function drivers with a named activation group and all your other programs star caller. That's it. That's step one. And of course, the rule is, if you touch it, you fix it. Don't go hunting for trouble. Don't decide to set up a project to go and find every single program and recompile every single program. You don't want to do that, because that will just stop any development and cause frustration. But if you have a change to make or a development to do or an enhancement to put into place, make sure that that actually gets, even if you have to modify additional programs which weren't in the original scope, put it into an ILE framework. And then you can begin changing your subroutines to procedures. And you'll begin to see common code. I mean, I'm sure you know some of the common code you've got. If you take that out and put it in a service program now and try and use it when you're not in an activation group, proper ILE activation group, it's not going to work. So you need to start small at the beginning. That is most definitely the way to go. Now, just to show where the boundaries are, this is the big picture. This is the whole operating system and the box. You have a system domain, which is separated from the user domain by a big wall. And the only way that you have access through that wall is through system-approved APIs, application programming interfaces. No other way you can do it. Within the user domain, each job has its own default activation group, and the behavior and the operation of each job is limited to the fence, which is the default activation group for that job. Be it an interactive job or a batch job, it still has exactly the same boundary. And so no job can interfere with another job. If something does go wrong, and I've occasionally had it, you get this weird, and it particularly happens when you're playing with pointers. You get, if you change the address or the address of a pointer, and you point outside your job space into somewhere else, you get, it's not actually such a polite message which says that you are now trying to interfere in a place where you should keep your nose out of, and your job will crash. That's all it does. It does not interfere. It just simply terminates your job with a severe error message to say you need, something's gone wrong. Doesn't happen often, but it can. Okay, so that really is a first pass through activation groups. I have later on other examples, but I would like any questions that you may have thought of, if you've got them at the moment, while I just take a 2-minute speak break. Okay. Other people are listening to me and have no questions, or they're not listening to me, one way or the other. Good. We have about 20 minutes, exactly 20 minutes. Oh, this daylight savings time is actually wonderful. Aha. I'm going to ask you to be more specific, Marinus. Because I don't think it's what you think it is. Right, let's have a look at the next topic. RPG 4 for integrated language environment. Pointers and data exports. We've done this once. I want to do it again. Because I want to go over this again because one of the things when you start binding modules together and you start using global data areas across modules and even from programs into service procedures, you begin to use pointers more and more and more. And it is most important that one understands the basis of pointers. Now, particularly when it comes to importing and exporting of data across modules. In the old days, when we used to call a program, we used to pass a bunch of parameters. You know, sometimes 20, 30 parameters were passed across to one, and some of them were input, and some of them were output, and some of them were I/O. And we used to get information back via parameters. And that's all very well up to a point when you're using program-to-program calls. But within a module, inside procedures, and when you are using ILE bound procedure calls, there are much more efficient ways of accessing the same data element. And this is the point. We're all about utilizing the same data, not creating duplicates of data, because every time you copy data, it creates a... Sorry guys, just hang on a second, I want to turn the lights on. It's getting a bit dark in here. Right. We want to try and use the same information in the same spaces, not move it around. Because moving data around a program or from program to program is an expensive business. It's time consuming. And also, of course, during a process like that, it can change content and all sorts of other things. So, pointers. This is just this is not the animated slide that you saw before. You have a system pointer, which is a 16-byte field. It's a system pointer. It's designated as a star in the type position, or if you are into free form, the word pointer in the declare DCLD, I think. Right. You can then work with offsets. Offsets are simple numerical values. And you can do arithmetic with pointers. Not only can you add an offset to a pointer to change its relative position. For example, SPP plus equals offset takes us down to this A, B, C, D, E here, because the offset was 83. So you can move a field based on a pointer. There's 3 fields based on a pointer. You can move these fields around memory simply by adding offsets to the pointer. But if I have a pointer that points to this 1, 2, 3, 4, 5 in module A, and I export that pointer to module B, and base a field in module B on that pointer, it's actually basing it on the field in module A. I will dig up an example to follow this up next week. Sorry, not next week, Thursday. We will look at some actual code where this is being played around with. So the idea is you can import and export pointers from one module to another. Now, if a pointer addresses a whole data structure, and you export that pointer, and you import it into another module, then you can base a data structure on that pointer in the second module, and you will have passed the entire contents of the data structure into the into the procedure call without having moved anything and without having provided any parameters whatsoever. And this makes the ability to create data buckets, places where you do data definitions. You keep them there, and you can access that data from service programs, from other procedures, from other modules all over the place. It eliminates the need to define and pass parameters all over the place, which again is a very, very efficient way of writing code. All right. I've got an illustration here. Right, let's just have a look at this. When I create a program from modules, like this one, using a create bound program, remember what I said, I don't know how many weeks ago. The global data definitions in each module, are available by using the import-export functionality across these 2 modules. The global data definitions are also available within a module to a procedure. So if this procedure wants information that's over here, I can export it from here, import it to here, and make it available to this procedure. So within a program, the data can be in any module, but it can be made available across all the modules within a single program. Remember, local data definitions are only available within that procedure, but global data definitions are available across modules using the import and the export keyword. It's similar with this one. Where am I? Sorry, I'm hopping around the place. Similar with this one. This one is a program with 2 modules, 2 main lines. These were taken from the previous ones. Again, the global data definitions can be made common. They're not common by default, but they require import-export functionality. Even within service programs, here's a create service program where the modules in a service program all have global data definitions. And these global data definitions can be common to the whole service program, which means they can be common to all procedures in a single service program. So procedures within a service program can communicate with each other, even though they're not being called from outside. Right, here's an example. There's just 2 very simple examples. Module 1 has 4 standalone fields. They're all exported and they're initialized on export. This one is a pointer. It's exported but not initialized. Here is a data structure. It has an export and it has an external name file A on export. Module 2 has exactly the same names here. The first 3 have the same names. Therefore, you do not have to specify them. If you want to import an exported field with a different name, you simply use the brackets. Now, there's a mistake here. This should be quoted. The name is quoted, and what it does is it imports UIEP as UIEX. Here you can see where the data structure is exported as file A, and you import as file A. External name file A. Import as external name file A. So that this data structure is in fact a file data structure exported from one module with that name, imported into another module with that name. And this means that between 2 modules, the same spaces are shared. It's not as if there's a copy. It's not as if there is any additional space utilized within the PAG. They are the same space. The space is defined and reserved in the module where the export is given, is defined, and is simply utilized on import. The one thing you need to remember from this, or with this, is that if you have multiple modules, 3 or 4 modules, bound together into a service program or a program, a particular field can only be exported once from that combination of programs. If you try and export the same field name more than once, you will get an error when you try and bind, because it says I've got duplicate names here. I don't know what to do with them. And that's why the rename is useful, because you can have it defined in one and imported as different names in different places. Okay, this is just a example of with arrows showing how across 3 modules you can make data available across all the modules and therefore all the procedures without passing a single parameter on any call. It's done internally at compile time by the operating system. So your global data definitions, when you start to modularize your code, your global data definitions become very important. And you start to build your data in one place and then share it across modules. It does make it easy. Your modules make it all the code a lot smaller. But it's easy to share these fields without having to worry about long, complicated parameter lists. In fact, in one of the AO applications, I have a data structure that contains something like about 22 pointers to different areas of the whole construct. And that data structure is based on a pointer that I then export to all the procedures that use that data structure. So those procedures have access to the data structure, which contains pointers to all sorts of different bits and pieces in the global data definitions around that particular program. So you can get pretty complicated, but it actually is highly efficient and very often a lot easier to actually understand, to code, and to debug. once you get the hang of it. Important is practice here. Please, don't be fooled into thinking that modernizing RPG and achieving a result and agility, smaller programs, less testing, and all the rest of those other lovely things that we list. Please don't think that this is something that doesn't need practice. And here again, I don't know how many senior managers or executives are listening here, but I would ask possibly that anybody who wants to can take this particular part of the recording and go and play it to their senior executives. That the benefits of moving towards modernized RPG for an integrated language environment are immense. The benefits of creation, productivity, testing, agility, all of these things are massive benefits. The problem is that people need the time to be able to apply these, to learn them, and to become proficient in them. And you guys need to be given the time to do this, to actually implement this new stuff, so that you can begin to reap the benefits of these as a result. Okay. Just about brings us to the end. This one doesn't even, strangely enough, have a question mark on it. So I'm assuming that at this point you understand everything. But just assume there's a question mark there in case you have any questions. Okay. Next week, or Thursday, I'm going to be doing a quick discussion on naming standards, programming naming standards particularly. So if there are any questions, I would very, very much like somebody to submit me some standards that you use that I can use as examples. And then we will get on with a couple of other topics like embedded SQL and such like. So I'm 3 minutes early, but thank you very much for your attention. I hope it went well, and I will see you next Thursday. This coming Thursday, not next Thursday. Thanks a lot.